In this series of videos, we're going to be discussing why data description is important and how to do it in the context of Jupyter and kind of data science. To give you an example of data description, what I want to show you is this map that an individual named John Snow, not that Jon Snow, John Snow made that was just illustrating the spread of disease. All he did was mapped out where people were getting sick. And by creating this map, they were able to learn that the reason people were getting sick was because they were drinking from the same wells. This is an example of data description. There's no analysis here, right? All it is describing the data in a different way. So that can be very valuable for analysis and for understanding what's going on in the world, even though it's relatively easy to do. The other important thing about data like this, just describing the data, is that it can help you, prevent you from making mistakes. You don't want to run a certain type of model on a data set that doesn't support it. Another great example of how we can learn things from data visualization is this graph. This was made by 538. And this is a graph that shows the Patriots and the New York Giants, so two NFL football teams. And so if you wanted to ask the question, when was the last time the Giants were better than the Patriots? You can look at this graph and immediately see that it's been almost 30 years because they're just such a terrible team. So data visualization helps you learn, and it's really step one. So we're going to be doing our own flavor of data visualization throughout this video. In the series of videos using this CFSAN Adverse Event Reporting System. This is a data set that is put together by the FDA, and what it is it records all of the different events that are reported from kind of consumers. So if you accidentally ate a Cheerio and you choked on it and you end up checking into a hospital, this database will record that particular event. So we're actually going to download this data. Now to download the data, so if you scroll down to the bottom of this, or the middle of this, the one we'll be using is this, the CARES, the January 2014 through March 2019. So this is the data set. Now, if for any reason this website no longer has this download link, so I'm doing this in August of 2019, and the FDA may decide to change things, what I've done as well is on the Data Doctor website, so datadoctor.io/datasets, under Lab 3, you can download the same file right here, as well as the PDF that describes all of that information. So this is your backup source. And this website right here, you can see the URL up at the top. You can also go here to download it directly from the source. So I'm going to go ahead and download this. We'll save this somewhere I can get to it quickly. And then I'm going to head over to Jupyter. So we're going to go ahead and get this data uploaded into Jupyter. So under my home directory here, I'll go ahead and click upload. And this is kind of the manual way to ingest data. So this is if you have a CSV on your local machine. And then we'll go to my downloads folder. I'll go ahead and click this and upload it. Now this is a fairly large file. We're in the hundreds of thousands of rows for the first time. So everything's going to take a little bit longer. So there we go. So here we go. It's 13 megabytes of data. And it's fairly large. So now we'll go ahead and jump into our Jupyter notebook. So I've named mine Lab 3 Descriptives, but it's just a blank file right now. And so we're going to go ahead and start our analysis on this data set. The first thing that we'll need to do is go ahead and type in %matplotlib inline. Don't worry too much about this command. We're going to put it at the top of almost all of these labs. And this just lets visualizations display within Jupyter Notebook. So we're going to use that a little bit later on. We're also going to use pandas here. So we're going to import pandas as PD. And so this is just to load the CSVs and do our data analysis. So first things first, let's go ahead and load in our data set. So we'll use pandas. Again, I've imported pandas as PD, so PD, and then read_CSV. And then in quotes and parentheses, what we're going to do is go ahead and put the name of the CSV. So I'll go ahead and I'm going to copy and paste this so that I don't accidentally misspell something. And then the other thing, just as a reminder, for almost all CSVs you load in, one of the things that you'll want to do is set this encoding. So this very specific encoding will allow you to open up most CSV files. Again, don't fret too much over what this is doing. Behind the scenes, it has to do with how characters are defined within operating systems, but just this is kind of a good default encoding that will allow you to open up almost all of this data. So this / means that the data file is in the same directory as my Lab3 Descriptives Jupyter notebook. So we'll go ahead and run this. And now we have our data. So in the same snippet here, you can do it in a different one, but I prefer to do any kind of manipulations in the same one. I'm going to go ahead and type in df.columns. So I just want to see kind of what the names of the columns I got are. So this is that set. And then I can also just type in df to print out the kind of example of what the actual data set looks like. So let's just take a moment to see what this data is. So every single row of data, these are all of the columns of data that we have. So there's a report ID, which is unique across all of the records. There's the date it was created in the system, the date it actually happened, a classification of what the FDA kind of decided was the classification of that particular row, the actual product that was involved in the complaint, its description, that is the type of product it was, and then many of them have the patient age, if it's in months or days or years, their sex, and then these kind of classifications. So in other words, what outcome did the event actually result in? So things like choking, right? So this particular individual had a vitamin of some kind, they were 70 years old, a female, and they choked on that vitamin. And so this got reported to the FDA. And you can see, many of these are, hospitalization, some of them are death. So it's really kind of disability. There's a wide range of different things that are reported. So let's do some very, very, very basic description. So let's look back at these columns. And the reason we want to look at the columns is we want to see exactly what they're named. So in this example, what we're going to do is we're going to take patient age. And I just want to see within the database what the kind of mean, mode, max, and min is for patient age. So I'm going to type in df patient age, and then all I have to do to get the average is type in .mean. And so when I run this, there we go. So I now know the mean patient age within that database is 53. Now there's some minor problems with this calculation that we'll get into in a moment, but this gives you a really quick way to look at the average of a column. So as another example, you can also do things like this. So patient age .max. And so if I run this, what I'll actually get, so this is now the max. And so as you can see, the maximum age is 104, right? Which is a fairly large age. So let's say I actually want to explore a little farther. I want to see for patients that have an age of 104, what did they report and how many were there? So what I'm going to do is I'm going to define a variable that has a selection. So I want to select certain rows from df. That is, if I look at the actual data frame, I only want to take the rows where a patient age is equal to 140 or 104. So to do that, what I'm going to do is I'll type in a variable. So you can name this variable, again, whatever you want. I'm calling this selections, but it's completely arbitrary what you name this. And I want that to be patient age equals 104. So what this is doing, and this I know looks a little bit complicated, but this is a fairly straightforward statement. So I'm saying I want to select every case where data frame, within my data frame, patient age, is exactly equal to 104. Importantly, one equal sign here means set this equal to this. Two equal signs here means check if this is equal to this. And so I'm going to show you real quick, if we actually copy this down here and I run this, you'll see this is going through every single row and it's reporting either true or false as to if this is equal to this. So I'm feeding this giant list of true or false into the data frame to select the appropriate records. So I'm going to go ahead and run this, and now I've created this new variable selections. And to get the selections, I can only then type in df selections. And so this will say, okay, go into data frame and only give me the rows that match this selection. So we'll run that. And voila, now we only have these 4 rows. And so these 4 rows are the 4 cases where the age, patient age was equal to 104. So we can go through these, right? We can kind of learn what happened. 2 of them resulted in death, right? So they ate Centrum Silver multivitamins. Not quite sure how that resulted in death, but who knows? Laxatives, right? I mean, there's these clear correlations, but there were 3 reports of 104. Now, the 4th report, it is 104, but then if we look at the description, it's formula. It's like, that's weird. And what we see is that in age units, we're actually looking at days, right? This is not years. So patient age can be recorded in both days and years. And so you have to actually specify that in future analyses, right? We only want to take cases where age is equal to years if we actually want to do an analysis based on years. So just descriptively, this is a good example of something where you need to take a look at your data. You want to make sure that you see things like this so that you can accept it in future analyses. So let's go a little bit farther in our descriptions. So let's say that we want to, for example, look and see what the most common causes of problems are within our own age range. So I'm going to assume that most of you sitting and watching this are college age, somewhere between 18 and 22. Now, you might be a little bit older, and you can adjust these numbers if you so desire. But I'm going to go ahead and redefine my selections. So I'm going to call this selections again. And again, you can call that whatever you want. But this time I'm going to make it a little bit more complicated. So first, I'm going to open up I'm going to start some parentheses here. And I'm going to say df patient age greater than or equal to 18. So that's the first thing that I want to be true for everything I'm going to select. Then after the parentheses, I'm going to hit space, and I'm going to type the number, an ampersand. And then I'm going to do the same thing, df patient age less than or equal to 22. And then you'll remember we have this problem of patient age can be in days or years, so we want to exclude any cases that are days. So the last thing we're going to do is and df age units, which is the name of this column here, so age units. And we only want to take cases where age units is equal to years. And that's it's years with a little parenthesis around it because the actual data has that. So I'm trying to match this exactly. So if I run this, now I have this new selections variable. Same thing as before, right? True and false statements. But now it's going to be true in cases where all 3 of these are met. So the only rows that will be true is where age is greater or equal to 18, less or equal to 22, and it's in years. So now I can choose that set of selections. So this one's going to be a little bit harder. We'll do df selections just to take a look at the data frame. And you can see in this particular case, we have a lot more rows of data, right? So this is 667 rows of data that meet these criteria. So it's a much larger database than we had before. So it's much harder for us to simply look at this data in its raw form and learn anything from it, right? In this case, we could look at 4 entries and we can say, oh, that's a problem. We can look and see the individual cases. Here we can't, like our brains just can't process that much data. So one thing we can do is we can use what's called a counter. So I'm going to do from collections import counter. And so this is just a tool that we're going to use to, you probably have guessed by now, to count. So counter is fairly straightforward. I'm going to say counter. I'm going to count from only my selections, right? So the data frame that matches this set of selections. And I want to count the number of times a product appears. So this is my kind of simple version. I want to count, okay, how many times does fish oil appear in the 600 database records? In these 600 records, how many times does fish oil appear? How many times does Chobani yogurt appear? And I want to see what the kind of top ones are. So this is the counter, and this will give me a list for every single case of how many times it appears. However, this isn't quite perfect, right? Because it's not sorted, so it just has the list in order of appearance. What I really want is the ones that are the most common. So to do that, I type in period most common. And if I run this, here we go. So now it's sorted. So exemption 4, this is actually a Freedom of Information Act issue where there are some companies that they will intentionally mask the data, so we can't really learn anything from that. Rather, the top 2 that we see that we actually have information on are Win Cleansing Conditioner and gluten-free Cheerios. So if you are between the ages of 18 and 22, the most common complaint to the FDA is actually Cheerios. So let's go a little bit deeper on this, though. Let's see how many times they even mention Cheerios. So one thing you'll see here is under product, there's many different ways. So Centrum Silver, multi-minerals, multivitamins, for example. That is, kind of one way to write Centrum Silver, but there's many different ways. You might just say the word Centrum. There might be some other brand of silver, right? And so you want to be able to identify every case that even mentions the word Centrum if you want to understand the impact of Centrum multivitamins. The same thing applies to Cheerios, right? Gluten-free Cheerios in particular, but there are certainly, many other types of Cheerios that we might care about. And so we want to actually take a look at some of the other ways that we can manipulate the data. So I'm going to stick with the same selections here. And what I'm going to do now is I'm actually going to do a count of the number of strings that contain the word Cheerios. So that's all I'm going to look at here. So let's for the sake of illustration, let's first look at this across the entire data set. So I'm going to print the product. So the product, because product, that's the column that would contain the word Cheerios. And then .str, because that tells Python that I want to do something with a string of words. It's not numbers that I'm manipulating. And then I want to count the number of times that Cheerios appears. And then finally, I want to sum that. So this will give me the sum of that count. So I'm going to run this, and voila. So in the full database, we see Cheerios appear 411 times. The reason this is the full database is because here we have df, there's no selections. So this is the entire database. When I run df selections here, it doesn't change df. All it means is look at df, but only look at these rows. When I type df without selections here, it becomes the original data set again. If I want to compare that to the number of people that have choked on Cheerios that are between the age of 18 and 22, that is my selections, then I type in this df selections product. Same thing as before, string count, Cheerios, .sum. So if I run this, here we go. So now we see 10. So if you'll remember, just a few minutes ago, there were 3 cases of the gluten-free Cheerios causing issue, and there are 10 cases here of the, any type of Cheerios causing issue. Now, one obvious conclusion would be, oh man, that's a lot, right? Like 411 people reporting issues with Cheerios, but we do want to look at how many records there are and the actual percentages that these represent. So let's take a look quickly. So let's say I'm going to print all records, and I'm just typing, you can type whatever you want in here. This is just to make things look a little bit prettier. And then underneath that, I'm going to print df.size. And this will tell me the size of df. So here you can see all records. So 960,000 records of data that we're processing right now. Then let's do print 18 to 22-year-olds. So this is the number of records that are just 18 to 22-year-olds. And we'll do df selection.size. So same exact thing, except now we're including the selection.
And selections.
So same exact thing, except we're including the selections. There we go. So 8,000 of those are 18 to 22-year-old. Now we're going to go into just a few other ways that you can manipulate these data frames to learn interesting things. So let's say that we only want to look at cases that resulted in death, so kind of the worst outcomes. So I'm going to create a new variable that I'm going to call death selection. And I'm going to set that equal to this, outcomes death. And so if you'll remember, so up here we have this column named outcomes. And of course, here's the value of death. So we want to identify what are the rows that actually have this value of death in them. That's what we're ultimately going to find with this particular search. Now, what this won't find is cases like this, right? So death, comma, medically important. It's not going to identify those cases because what we're doing here is, looking for an exact text match. And so later on, in a later video in this section, we're going to talk a little bit about how to do a fuzzy match where we're just kind of looking more broadly for the word death. It's going to be very, very similar to how we did the Cheerios search down here. But for now, let's just look at the ones that are strictly death. So I'm going to go ahead and run this. So just real briefly, we'll print out the death selection size that we just did a moment ago, and we'll just divide that by the size of the entire data frame, right? So we're just looking at the total divided by how big this is. I'm going to go ahead and multiply this by 100 this time, so I didn't do that up above. So this time it will be a true percentage, and that needs to be on the inside. And there we go. So almost 7% of these cases are actually resulting in death. Now, also interestingly, let's find out what the most common products that are associated with death are. So let's do the counter that we did before, and we're only going to look at the death selection this time. We want to know what the products are that are most commonly associated, and we'll do the most common that we did before as well. And here we go. So 5,000 cases where we don't know, right? There's an exemption. The first one we do know, and this is pretty interesting, is kratom, right? So kratom, we have 100 instances of death, and then that drops all the way down to 5 for the next one. Now, the reason this drops so far could be simply that kratom, that's the only word there's no other version of kratom. It's just kratom. Whereas Centrum, you have the Centrum multiminerals, etc., etc. But irrespective, don't use kratom. And with that, that'll be the end of this first video. So in the next video, we'll start looking in a little bit more into how you can use some visualization to look at the distributions of your underlying data.